Number 6, Jonathan took a survey of his friends and how many siblings each of them has. In the first column, the number of siblings from 0 to 4, and in the second column, the number of friends that number of siblings. So we have 3, 0, 2, 3, 2. So we want to look at this a little bit carefully. What are they trying to say right here is that we have 3 friends that have 0 siblings. So I have 0, 0, 0. And we have kind of this idea here. So let's continue reading. What is the median number of siblings for the data in the chart? So for median, we're really labeling things from the least going to the greatest. So what we want to do here is that, well, the smallest numbers is 0, and we see that the largest numbers is actually 4. So where do we see this 4 here? So right here, we have 2 sets of 4s. So let's start arranging these siblings, the number of siblings I have. So we have 0, 1 siblings. Right here, it's that we have 2 siblings. So I'm going to continue this list with 2, 2. And then over here in the third line now, well, this tells us that we have 3 of his friends have 3 siblings each. So we continue with 3, 3, 3. And again, to finish off with our 4s down here. So then we're finishing off with 2 more 4s. And let's take care of those. So now this is our list from least to greatest. Now, when we're looking for the median again, we're looking for the middle number. So we start canceling the values off on each side. So I cancel off a 0, I'll cancel off one of these 4s. I'll cancel another 0, I'll cancel off another 4, cancel a 0, cancel now a 3, cancel a 2, now I cancel out a 3. So what we have now is we have 2 values here, and the median has to be between these 2. So in order to figure out what it is, we're going to add these 2 numbers together, divide by 2. So I have 5 divided by 2, which is going to end up being 2.5. So our answer here is C. Now continuing. Number 7. So in number 7, we actually have 2 ways to think about this problem. We can either divide by -3 to both sides right away, or do distribution. So I'm going to first show this problem done using distribution. So this is our first method. I'm going to grab this question, and it says, well, in number 7, which describe all values of x for which -3 parentheses x plus 2 close parentheses greater than or equal to 6. So here I'm going to use distribution. So I'm distribute the -3 to everything inside. So I now have -3x minus 6 is greater than or equal to +6. Then I just continue the regular solving process. So I'm going to add 6 to both sides. So on the left, we'll have -3x is greater than or equal to +12. Then here, I'm going to divide both sides by -3. But we have to remind ourselves, whenever we divide by negatives, we have to also switch the inequality. So we're going to flip this. Now it's going to say less than or equal to. On the left, this simplifies the -3s, and then we are just left with x. And on the right side, we're just dividing 12 by -3, which would now give us -4. And so that'll be our answer. We have x is less than or equal to -4, and that should be part B. So now what I want to do here is our second method. So here we go. I'm going to do this problem one more time. Without distribution. So this will be our second method. It's good to know multiple methods to solve a problem so that we can decide what is the best option for us. So I'm going to copy this question down one more time. So if I'm not doing distribution, what I'm going to actually do first is divide both sides by -3. again, here is when we have to check to switch our inequality symbol right away, because we're either dividing or multiplying by -3. In this case, dividing by negatives. So we switch from greater than to less than or equal to. And on the left-hand side, the 3's cancel out, or really the -3's cancel out. So we're just left with x plus 2. And then on the right-hand side, I have 6 divided by -3, so this gives us -2. Then our next step now is to subtract 2 to both sides of our equation. We are left with x is less than or equal to -4. And this answer works out. It's the same as our method 1, and this matches part B again. So we are for sure now that in number 7, the answer is B. Now continuing. Number 8. There are 6 feet in 1 fathom. Okay, so that's information we should keep track of. So right here, okay, so I'm going to write 6 feet equals 1 fathom. Then we keep on going. There are 5,280 feet in 1 mile. Great. I'm going to continue writing this information down. 5,280 feet is equal to 1 mile. Then we keep on going here. If a car is traveling at 60 miles per hour, okay, so this is telling us we have a rate is equal to 60 miles over 1 hour. Then we keep reading, which expression has the value equal to the car speed in fathoms per minute? So, here's another change we're looking for, something in per minute. So right here, we want to recall this time change here. So we're thinking about, well, if we have a problem in hours and we need minutes. So we remind ourselves we have 60 minutes is equal to 1 hour. So what we can actually do here is create a number 1 out of this to remind us how we can multiply everything by the number 1. So secretly, I'm going to divide both sides here by 60 minutes. So I'm going to have a 1 is equal to 1 hour over 60 minutes. And this is our key idea for the rest of this problem. So right now, I'm going to grab the rate is equal to 60 miles over 1 hour. And I'm going to multiply this by the number 1. However, our 1's going to look a little bit strange. It's going to be 1 hour over 60 minutes. And since we want to convert miles into fathoms, we need to start changing some of these other values above here, things that we kept track of. So what this tells us in our feet to mile statement, that we can have another 1 here. So this 1 will represent 5,280 feet over 1 mile. So that's what we also need to multiply in right here. We have 5,280 feet over 1 mile. And we're converting our fathoms as well. So right here, what we want to have, fathom on top. So we can have 1 fathom over 6 feet. So that's the last thing we need to multiply for the statement. So let's move this rate a little bit below here so that we have more space. Fill this in. And let's write our last multiplication of another 1 of 1 fathom over 6 feet. So all we have to do now is match the numbers. Are we canceling out all the dimensions correctly? So meaning our miles are canceling out, great. Our feet gets canceled out, excellent there. So great, now it's in terms of fathom. Then we're canceling out our hours, and there you go. we now have something that's in fathom per minute. So we're just looking at the multiples now. So I have 60 times 5,280 on top, right there. And then on the bottom, I really just have 6 times 60 right there. So part A is our final answer. And that's it for number 8, AAR dimensional analysis problem. On to number 9. It reads as follows. A 6-foot pole casts a shadow of 5 feet. How tall is a tree with a shadow of 13 feet? So moving on to number 9. It reads as follows. A 10-foot pole casts a shadow of 5 feet. How tall is a tree with a shadow of 13 feet? So let's start sketching out a picture for ourselves. So we have some kind of pole here. And this is 10 feet pole. Then it casts a shadow here of 5 feet. In our next picture, we're now just kind of sketching a tree. So we have some kind of tree. So here's our tree. It is an unknown height. So let's just call this H. And it casts a shadow here. So our tree has its own shadow. And it is 13 feet. So if you look at this, this really looks like a similar triangle problem. So what we have actually is 2 similar right triangles. So this is great. We can set up a proportion now to the height over the base compared to our height of the tree and to the base of the shadow the tree creates. So we're going to take this proportionate and start substituting in our values. So we have 10 feet over 5 feet is equal to our unknown height h over 13. Then we solve for our height by multiplying both sides by 13. So we're going to start simplifying the left-hand side. So we have 13 times 2 is equal to h, and 13 times 2 gives us 26, and this is equal to h. So our height here is 26 feet, and that's it. Now, on to number 10. Number 10 reads as follows. The formula for the volume of a cylinder is pi r squared h. Sounds good? Now, we're given 2 pictures. Figure out our figures are not drawn to scale, so that's something we all should always expect. Don't expect our figures to be drawn to scale. Continuing, estimate how many times would one be able to fill a cube of side length of 2 with water and then pour its content into a cylinder with a radius of 4 and height 4. So all they're really trying to tell us is we're going to pour water into our cube, then see how many cubes we can pour into our cylinders. So we're going to first start off with the volume of our cylinder. So they gave us the formula. The volume of the cylinder is equal to pi RH. So we want to label out all the information they gave us. Well, R is equal to 4, and the height is equal to 4. So this tells us our volume now is equal to pi times 4 squared times 4. So this gives us our volume of our cylinder is equal to 64 pi. Now we want to see what the volume of our cube is. So they're telling us, well, one side of the volume of the cube is 2. So remind ourselves the equation for cube is really x times x times x, or just x cubed. So our volume here of the cube is equal to 2 cubed, which gives us 8. So how can we finish this problem? Notice that they just want us to estimate the solution here. So if we estimate 64 pi, well, that's kind of like just saying 64 times 3. And that's really close enough. So 64 times 3 is approximately 192. Okay, so we continue with this problem now. What we end up having is we're taking the volume of a cylinder and we're going to divide it by the volume of the cube. So this is going to give us our approximation. So our volume of the cylinder is about 192. Our volume of the cube is 8. Then so we just want to say, hey, okay, which one of these matches these answers closely? So if we take 182 divided by 8, that's going to be approximately 24. So this gives us 24 as our approximation. So that means our answer is going to be B. The cube can be poured about 24 times or 25 times, we're rounding a little bit up, into the cylinder. And that's it for number 10.